So we're going to look at the following. Let's suppose I have an n by n square, S, and it's composed of n squared 1 by 1 squares for all integers k with 1 less than or equal to k less than or equal to n. How many different k by k squares does S contain? So we're going to look at an example here for n. Let's consider n equals to 3. So I'm looking at a 3 by 3 square, and it's made up of 9 1 by 1 squares. So k takes on the value. K is between 1 and 3. So we're going to look at all of the possible k values for k. So k being 1. How many 1 by 1 squares are there? There are 9 in total, right? Each one of these right here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the 1 by 1 squares there. All right. And now let's look at k being 2. If k is 2, I'm looking at 2 by 2 squares. How many 2 by 2 squares do I have? Well, maybe I'll just outline them. Here's 1 2 by 2. Here's another 2 by 2. Here's another 2 by 2. Here's another 2 by 2, and then here's our another 2 by 2. So in total there are 4 2 by 2. And the last one, if k is 3, how many 3 by 3 squares are there in this picture? Well, there's only just the whole square, so there's 1. And so what we want to do is we want to add these up, because I'm trying to look at the total number here. 1 plus 4 plus 9. Well, those are all squares, right? So this is 1 squared plus 2 squared plus 3 squared, and that's 14. So I'll say in general, S contains a total of a summation from k equals 1 to n, k squared, different k by k squares. So this pattern that we saw back here is what we always have. And so now what I want to know is there a compact formula? Sometimes this is also called a closed formula for the summation k equals 1 to n k squared? And the answer is yes, there is a formula. The summation from k equals 1 to n of k squared is equal to n plus 1 to n plus 1 over 6. So you might have seen this formula before, probably in calculus. And in our next video, we're going to prove this using mathematical induction.